this is a joint paper with Peter, who is here to answer questions. I want to just say that, like, I don't know if you guys know or not, I had a brain injury, so I'll be slow. 2, I will forget some words. So please ask whenever I was unclear and I was using the wrong word, please feel free to ask questions. That's like totally normal. Okay, so what we all agree on is that economies are subject to cycles. When I talk about cycles, I'm basically talking about succession of good times and bad times, in which good times are usually associated with abundant credit at small spread, even to riskier firms, and which unfortunately comes with a deterioration of credit quality. So you can think about this as high credit market sentiments or overheated markets. At the same time, output is usually high and there is positive output growth. Then the economy goes usually into a bad time in which risky firms are squeezed and credit is expensive, even if it's available, even to good firms. However, the issued credit is, on the other hand, of higher quality. So you can think about this as low credit market sentiments, which is usually accompanied by low output and negative output growth. So a very, very natural question is, how should the policy respond to these fluctuations, if it is to respond at all? So in order to understand this question, we would like to understand in this paper, what are the things that predictably trigger periods of credit market overheating, this transition of good times to recessions, as well as the length of booms and recessions. Then with this in hand, we want to understand whether this economy is constraint efficient. And then if it's not, what are the costs and benefits of some policy instruments? All right, so what the model will basically say is this slide. So where the model relies heavily on what I would like to call quasi sentiments, because it's perfectly irrational, and sentiment is usually has like an irrationality sense to it. So I want to call it quasi sentiment. It's going to boil down to choice of lending standards. So in this perfectly irrational model, there's going to be this two-way interaction between quasi sentiments, which I will be very precise what I mean by that, but you have to give me a couple of slides, and real outcomes. So think about it as, okay, investors or lenders are imposing lax lending standards for whatever reason. Then that would be accompanied by a credit market and real boom. However, the fundamentals will deteriorate. Once the fundamentals have deteriorated enough, these lenders are, oh my God, why are we imposing such lax standards? Let us switch optimally and rationally to tight standards. So once they impose tight standards, then there's going to be a credit squeeze, and then there's going to be a real downturn. However, only the best of the firms can get financing, so fundamentals improve. Once the fundamentals have improved enough, the same guys are like, oh my God, why are we doing these tight standards? So, and we're giving up on all these great investment opportunities. Let us use lax lending standards instead. And so the circle continues. In that sense, this model leads to endogenous cycles. So what we want to think about in this paper is this emergence and properties of these cycles, as well as some policy instruments. So if there are no questions, let me jump into the setup, because I'm going to anyways miserably run out of time. So this is like a very simple model. There is one good and there is infinite horizon. Each day is divided between morning and evening. There are two types of agents in the model. There's going to be entrepreneurs who produce and investors who provide funding. Everybody is reasoning, I mean, whatever you want, just think the simplest possible thing that you can even imagine. Everybody is risk neutral. Everybody maximize expected lifetime utility. Everybody receives 1 unit of endowment every morning. And then every agent can save at this interest rate, 1 plus RF within period, but there is no overnight saving. So we're going to completely shut that down. Now, let me talk about the agents. The first set of agents are entrepreneurs. And the key to this model is a type distribution of entrepreneurs. There's a unit measure of entrepreneurs, and each entrepreneur, importantly, has a two-dimensional type. The first dimension is that the entrepreneur is either good or bad. We will gonna denote that by tau. each entrepreneur is either transparent. The second dimension is each entrepreneur is either transparent or opaque, which we're going to denote by omega. I totally understand that this is completely like words which make no sense. You have to give me a couple of minutes and I will be very clear about all of them. Now, let me introduce some notation. Let mu denote the measure of bad entrepreneurs in the economy. This table that you can see here basically clarifies that there are 4 types of entrepreneurs from this 2x2 type distribution. If tau is G, that's good entrepreneurs. If tau is B, that's bad entrepreneurs. Omega equal 1 is transparent entrepreneurs, and omega equal 0 is opaque entrepreneurs. So throughout the talk, you have to believe me in a lot of things. So with this introduction of notation, let mu1 denote the measure of bad transparent entrepreneur. Remember, mu was measure of bad and 1 was transparent. On the other hand, mu0t is the measure of bad opaque entrepreneurs. There's the t everywhere because this is a dynamic model. The last thing I want to see in this slide is that you can see that I've made the measure of bad opaque entrepreneurs, mu0, red. The reason is that it's going to turn out that for almost all of the stock, this is going to be the only state variable of the economy. More generally, both of these mu's are the state variable, but for all of the stock, except possibly one slide, the only state variable is mu0. Now, let's think about the dynamics of this type distribution. The model is a stochastic OLG model, and each entrepreneur is replaced by a newborn each period under 2 circumstances. The entrepreneur might die with an exogenous probability delta, completely randomly, or if the entrepreneur is not granted credit, he's gonna die, okay? And the newborn comes from this outside distribution, which has a fixed proportions. In the outside distribution, lambda fraction of entrepreneurs are bad, 1 minus lambda are good, and 1/2 are opaque, and 1/2 are transparent, and these 2 types are distributed IID. This means this assumption of like when the entrepreneurs are replaced implies that the entrepreneur type distribution is endogenously determined by the credit market outcomes. So because in some credit markets are given different credit market outcomes, different entrepreneurs will not be granted credit and different ones die. And that means that the fraction of bad opaque entrepreneurs and the fraction of good opaque entrepreneurs are both endogenous and they're time varying, and there will be in general our state variables. Okay, the technology of entrepreneurs is as easy as you can imagine. Each entrepreneur chooses an investment level given his type in the morning, and he's going to produce with a linear technology. Each entrepreneur is going to also obtain credit, which we're going to denote by L, at interest rate R, and both of these are entrepreneur specific, again in the morning. Now, each unit of investment has a cost and a benefit. The cost is 1, and the cost can be covered by 2 sources, either the 1 unit of endowment, which the entrepreneur received in the morning, or with the credit that he received, that he obtained that day. Also, in terms of kind of the return, it's going to return rho. Remember, I said it's a linear technology, and the return of the project is higher than the risk-free, and the return is that same evening. Now, in order to basically enforce repayment, credit, this is an assumption, credit has to be collateralized by investment. That means the total, like totally classically, the total repayment that the entrepreneur has to repay, which is 1 plus RL, it has to be limited by his investment. Then you can solve for it, and that says that basically the credit that the entrepreneur receives is inversely correlated with the interest rate that he faces. So if the entrepreneur faces a very large interest rate, he can raise very little. If he faces very little interest rate, he can raise a lot. So these are all super classic. And then another way to think about it is that financing each unit of investment requires R down payment, and this down payment has to be done by entrepreneurs' own endowment. Now comes the first friction, which tells you what does good versus bad mean. So this is basically G versus B, okay? The friction is that, one friction is that the bad collateral is not seizable, okay? That means bad entrepreneurs will not pay back. that also mean that the opacity, the part of the type which is is characterized by opacity versus transparency, does not matter for the repayment, for the return on investment. So whether the entrepreneur pays back or not only has to do with good or bad. Now we're done with entrepreneurs. Let's move to investors. Each investors are super simple, accepts their information. So each investor lives one period and is replaced by the same type of investor next day. There are two types of investors. Some of them are skilled. There's a small measured W1 of them. And these skilled investors, skill means they exactly observe the type of entrepreneur or project. So the two-dimensional type, they exactly see who you are. You're good or bad, you're opaque or transparent. There is a large measure of entrepreneurs denoted by W0, which are unskilled. The trick is that they only receive imperfect signals on the sample of loan applications that they receive. And this is the critical part of the paper. So if there is one thing you remember from the talk, I want you to remember this item and the next slide, and that's it. So the signals that the unskilled investors receive comes from a test of their choice. And this test costs C. And basically the second part of the entrepreneur type distribution, which is opacity versus transparency, is only defined by how entrepreneurs perform in investors' tests. Okay. So this part of the type is only defined vis-a-vis investors. Okay, so now here are the two tests. So as I said, in this slide, the unskilled investors receive only imperfect signals. So no matter what test they choose, they will make mistakes about some entrepreneurs, okay? So it is not like one test makes them better informed. They always make mistakes about some projects. What type of mistake they make is different, okay? So the two tests, we call the first one bold and the second type cautious. So let me go through what these tests are. The first thing to realize is that these tests make no mistakes about transparent entrepreneurs. So both tests return perfectly correct answers about transparent entrepreneurs. They make different type of mistakes about opaque entrepreneurs. So in that sense, opacity means these tests, you are an entrepreneur, that these tests make a mistake about you. So a bold test is a test that makes false positive mistakes. What does false positive mistake means? It means it pools all the bad opaque entrepreneurs with all the good entrepreneurs. So for every good entrepreneur, whether transparent or opaque, is going to pass the bold test. That's kind of the green tick. And bad opaque entrepreneurs also test the bold test. Okay, so this test basically does not can characterize all good investment opportunities. However, it pools some bad ones with it too, which is false positive mistake. The cautious test is exactly the opposite. So the cautious test makes false negative mistake. That means it pools good opaque investment or projects with all the bad ones. So every bad project, no matter transparent or opaque, is going to fail the cautious test. However, opaque good projects also fail the cautious test. So this is false negative mistakes. And kind of to give you an overview, this is what I like to call quasi sentiment. So this looks like sentiment. So it looks like an investor who chooses a bold test is bold. He does not want to give up on any good investment, while an investor who chooses a cautious test is very cautious. He does not want to finance any bad investment. To give you a comparison with the benchmark, imagine a skilled investor. A skilled investor says good whenever the project is actually good, regardless of transparent or opaque, and says bad whenever it's bad. So you can see that the two tests make mistakes about different types of opaque entrepreneurs. right? So it makes it clear that both tests make mistakes. Now, to be very clear, we also, so you can see that this is only two tests, two extreme cases. So we also, in the appendix, we saw for generalization, which we allow for all the family of tests, which with probability alpha return bold, and with probability 1 minus alpha return cautious. It's going to turn out that the problem is convex. So if the investor can choose between the whole continuum, only chooses the two endpoints. So restricting the choices with the two endpoints is without loss of generality. All right, so now with this information friction, I can tell you what the main frictions of the model are. The first one is about whether being bad or good, which is basically bad entrepreneurs do not pay back. So investors, if they can, they only want to lend to good entrepreneurs. However, investors have only imperfect information about entrepreneurs type, and they have to choose this test. So given that, then there's a credit market, which each day, each investor advertises the interest rate R at which he is willing to lend. Then each unskilled investor pays cost C and picks his test. And then each entrepreneur submits credit demand at all the interest rates that he wants, and then markets clear at each interest rate, and demand should be equal to supply. So
you said there are some investors that are perfectly informed.
Yes, there's going to be exactly. There's going to be a small measure of investors who are perfectly informed.
Just to close the model.
No, so I'll tell you exactly. So you can close the model without them. It's perfectly fine. One thing you would not. So I want to get that in bad times, the credit market is segmented. Okay, and if I don't have them, the credit market would not be segmented. So that's their role. That's a very good question. Okay, so now you should believe me in this key. This is our key result. Okay, but you should believe me. I'm not gonna prove it here. And within each day, investors choose the bold test if and only if there are few bad opaque entrepreneurs. And this result is very intuitive. The intuition is that there is a quality-quantity trade-off. Bold test leads to more lending. However, some borrowers, the bad opaque ones, are going to default. So if the fraction of bad opaque borrowers are high, which is large mu 0, that would lead to more defaults and means more cost, more interest rate required for the bold investors. As such, the cautious investors can offer lower interest rate than bold ones if bad opaque entrepreneurs are a lot. So I'm gonna assume, I'm gonna restrict the parameters, okay? And for the parameters that I'm gonna focus on, this is the key intermediate result. Basically, if the fraction of bad opaque entrepreneurs is less than this threshold, which is basically cost divided by the interest rate, then all the investors choose the bold test, okay? And with some abuse of language, I'm gonna call this bold stage, okay? On the other hand, if the fraction of bad opaque entrepreneurs is above that threshold, all the investors choose the cautious stage, and then I'm gonna call that the cautious stage. So the bold stage is characterized by investors who lend to all the good entrepreneurs and some bad ones. So investment and output are both high. And importantly, all entrepreneurs face the same interest rate. So in a sense, there is a pooling equilibrium between all the good entrepreneurs and the bad ones who can raise financing. And this interest rate is lower. However, the loan quality is low because some of the bad entrepreneurs also get financing. So this is like a booming economy and overheated credit market. So in that sense, choosing the bold test, which is an information regime, if you want, I want to think about it as this mimics being sentimental, quasi sentiments, mimics the sentiment that you as an investor do not want to give up on any good investment opportunities. In the cautious state, on the other hand, investors only lend to good, transparent firms when they're unskilled. So the good opaque are constrained by only scarce capital of the skilled, exactly as Vero mentioned. So these guys face limited capital, they face very high interest rates, and they have produced low output. So, and that leads to a credit spread which is basically this dispersion in interest rate. However, no bad entrepreneur is able to get credit, and that pushes the investment and output even lower. However, that pushes the loan quality high. So this is like a quasi sentiment that you as an investor are like, oh, I want to make sure I don't invest in any bad project, although I know that I will give up some good investment. So this looks like low credit market sentiment. So now let me tell you what the equilibrium looks like, and I will talk about it mostly through a picture. So the dynamics of the model, believe me, there's going to be one state variable, the law of motion for fraction of bad, opaque entrepreneurs. Remember, first, let's compare two potential steady states. A steady state where every investor is cautious, a steady state where every investor is bold. In a cautious steady state, bad entrepreneurs die at higher rate because they were getting no financing. That means the fraction in the steady state, the fraction of bad opaque entrepreneurs is lower if every investor is cautious versus if every investor is bold. However, in terms of the movements, remember the key intermediate result says that investors become cautious only when mu0 is above a threshold. So if that threshold is between the two steady state values, then we will be in a cycle. And it's easier to look at it here. So on the x-axis is time, once the economy has reached the steady state cycle. On the y-axis is the fraction of bad opaque entrepreneurs, mu0, which is the state variable of the economy. The green line is basically mu0c, is the fraction of bad opaque entrepreneurs in a steady state that every investor is cautious. And the red is mu0b bar, the fraction of bad opaque entrepreneurs in a steady state where everybody is, every investor is bold. And the purple line at the end is basically the threshold of switching, C divided by 1 plus RF. So above this threshold, every investor seems to be cautious. Below this threshold, every investor wants to be bold, okay? So now imagine we're at time 5, where the fraction of bad opaque entrepreneurs is kind of low, lower than the switching threshold. That means investors choose to be bold. That means some bad entrepreneurs raise funding, so their fraction keeps growing. It keeps growing and goes toward the steady state level of bad opaque entrepreneurs under a bold. That's an attraction point. However, the critical thing is because this threshold, this switching threshold, is below the steady state, for sure the fraction of bad opaque entrepreneurs passes the threshold of switching before hitting the steady state. And once it passes the threshold, once the fraction of bad opaque entrepreneurs becomes large enough, every investor is like, oh my God, there is so many bad opaque entrepreneurs, so let me switch standards and become tight. And so impose tight lending standards. That means no bad entrepreneur can get financing, and the fraction of bad opaque entrepreneurs falls. And then we again go to the bold threshold. So you can see.
Yes, you have a couple of minutes left.
Yes, exactly. Thank you very much. So that means, so this is clearly a cycle. This cycle never converges. So this is the cycle. This is going to go forever. This is like, and then if you look at this is a macro conference, if you look at the output growth, you can see that when the investors are all bold, during the bold stage, the output growth is positive. However, throughout the bold stage, it's falling. Why? Because throughout the bold stage, throughout credit market overheating and throughout having good sentiments, the fraction of bad entrepreneurs rises. That means investors require higher interest rate in lending. That means entrepreneurs can borrow less, so they can invest less. So the output growth, although it's positive, it keeps falling. Once everybody goes to tight lending standards and there is a collapse, then the output growth becomes negative and then again positive. So you can see that this is like a long boom and a short recession. And then the credit spread, the credit spread is, there is no spread in good times and there is spread in bad times. So this is not the only class of cycles that the market can, that the model can generate. In particular, there are three broad classes of cycles. One is normal expansion and contractions, which is what I showed. The model can generate prolonged recoveries, and it can generate double dip recessions. For double dip recessions, we need to go to the parameters where there are two state variables. But because I'm going to run out of time, I'm not going to talk about them. So let me just use my last seconds to talk about policy. So now consider a constraint planner. He's very constrained. He can choose only the tests that the investors run. In particular, he can choose it in a very particular way. He can only change the bold cautious threshold. Remember, in equilibrium, there is a threshold. Above that threshold, every investor chooses to be cautious. Below, every investor chooses to be bold. The planner can choose that. It's going to turn out that the constrained optimal outcome is often cyclical. However, the equilibrium is not constraint efficient. Okay, and the reason is a dynamic inefficiency, which is a little weird, but that's what happens in this model. In this model, the cautious stage, of course, has a contemporaneous welfare loss. However, it has a dynamic welfare gain. The reason is that cautious stages keep fraction of bad projects at bay, because basically when we enter a cautious stage, the fundamentals improve. And that makes booms more welfare enhancing. So in that sense, in this model, cautious states are not horrible objects, and that's the reason that the constrained optimal outcome is also cyclical. However, individuals do not internalize this effect on the evolution of state. So we look to think about the difference between the equilibrium and this constraint optimal. We focus on three simple policies. There's a simple monetary policy, there's a counter-cyclical monetary policy, and macroprudential policy. And you want to think about how they rank. And this is the end of the talk. So on the x-axis will be the threshold that this constraint planner chooses. So above mu hat 0 planner, every investor will be cautious. Below that, every investor will be bold. The two vertical black line is basically determine the region in between which the constrained optimal economy becomes cyclical. Outside, it's only bold or only cautious. Okay. Now, and then on the y-axis is the mean welfare over the cycle. So the lines, the green line is basically the planner expected mean welfare over the cycle, which comes from that particular mu 0 hat. The purple line is counter-cyclical monetary policy welfare. The blue is capital requirements, and the orange is simple monetary. You can see that we can clearly see their ranking. So let's first start from the baseline economy, which is the blue dot. So the blue dot happens at a particular threshold. Now you can see that the green line is maximized at a smaller threshold, right? That means that the planner wants more often recessions, so the planner wants investors to be cautious more often than what they are in equilibrium because of this purifying effect of cautious stages. On the other hand, you see that all three policies are costly, and the reason is that all of them increase the cost of capital, okay? Well, either by having a higher interest rate or by having capital requirements, and that means they bring the investment down. And you can see that there's a clear ranking. Simple monetary policy sucks. However, capital requirements and counter-cyclical monetary policy.
Seriously.
Yes, so these two do very similar. Yes, so let me conclude by saying that this is a model where there is two-way interaction between rational quasi-sentiments and real outcome, which leads to endogenous cycles. Thank you.
So thank you very much for inviting me to discuss. It's been great to read the paper. It was a lot of fun. And so what I'm going to do is just quickly go over the broad overview of the paper and focus mostly on how this distribution changes that Maryam was talking about and how to generate these cycles. So you think about what's the big question that they're after is like, what drives economic cycles, right? And the answer that they're going to give is, well, rational sentiment. And this is the last time that I'm going to use this word. Like, I'm going to talk about lending standards, right? So rational sentiments in the paper are just lending standards, and I'm just going to talk about how these lending standards are determined. And in fact, in the paper, the credit market frictions are going to determine the choice of lending standard by investors. It's going to be two key frictions. One is the imperfect pledgeability, in particular that bad entrepreneurs do not repay their loans ever. And the other one is that there's imperfect information, that entrepreneur type is not observed, right? So with these two frictions, then there's a trade-off when investors have to choose which lending standard they want. They can choose a very lax lending standard and then make a lot of loans, but also face a lot of defaults. Or they can also choose more stringent lending standards, lend less, but have fewer defaults. So there's going to be this trade-off between the quantity and the quality of lending that they're going to have in their portfolios. So the lending standards that investors choose are going to then determine who survives, so the distribution of investor types, and the interaction between these two things are going to end up determining the real outcomes of the economy. So I'm going to focus solely on this link between lending standards and the distribution of investors, and how the lending standards affect the evolution of the distribution, and how the distribution then is going to affect the lending standards. And in the paper, they do a fantastic job linking it to real outcomes and the interest rates. I just want to focus on what is driving the cycle mostly. So the stage economy, so in one period, you have two sub-periods, just one good. And there's going to be two types of risk-neutral agents. You have heterogeneous entrepreneurs who can be good and bad, transparent and opaque. And you also have heterogeneous investors who can be either skilled or unskilled. As I mentioned before, there's a credit market friction in which like bad entrepreneurs do not repay their loans. So in the morning, investors and entrepreneurs are going to go to the credit market, and some investors are going to get credit, some entrepreneurs are going to get credit, and then they're going to produce. And then once they produce in the afternoon, they're going to repay their loans if they're not bad. In terms of the information structure, agent types are going to be private information. So skilled investors are going to be able to observe the entrepreneur's type perfectly. Unskilled investors, on the other hand, are not going to observe the entrepreneur's type, but they can choose to screen entrepreneurs by choosing credit standards. And these credit standards, the shape and the choice of these credit standards is key in determining the cycle. So this is what happens. So all of these black dots are entrepreneurs in our model, right? And they can be either transparent or opaque, good or bad. Now, if I'm an investor and I choose a bold test, and I'm going to lend only to those investors that pass my test, then the ones who are going to pass are all of these red X's, right? The bold test is going to pull together all of the good entrepreneurs plus the bad opaque ones, right? Now, if I choose a cautious test, I'm only going to identify transparent good ones. So the transparent good entrepreneurs are the only ones who are going to pass my test. So now you can see that if I choose the bold test, I'm going to be making a lot of loans. There's a lot of red X's, but I'm also going to be lending to bad opaque entrepreneurs who are not going to repay the loans back. So I have more lending, but more defaults. If I choose a cautious test, I'm not, as an unskilled investor, I'm only going to make loans to good, transparent entrepreneurs, and I'm going to face 0 defaults. So this is the trade-off between quality and quantity of credit. Now, once we know these tests, well, the stage equilibrium, what investors are going to choose, is going to depend on how likely it is that I'm picking up opaque bad entrepreneurs. And that depends on the distribution of entrepreneur types. And as Maryam mentioned, it's really nice that in the paper, it just boils down to how many bad entrepreneurs that are opaque are there in the model, right? Basically, how many little X's we have in this lower quadrant. Okay. So what happens when we get to the dynamics? This is going to be just a repeated stage game. There's no saving within periods, but the periods are going to be linked by the evolution of entrepreneur types. That's going to be endogenous. So the distribution of entrepreneur types with which we stand in period t+1 is going to be determined by the lending standards at time t. And that's the really nice thing about the paper. That's the way in which they generate these endogenous cycles. The evolution of entrepreneur types is going to have some endogenous and endogenous components. The entrepreneurs who exit are going to be replaced by new entrants. Some of them are going to just die, and it's going to be an exogenous exit rate. But also, all of the entrepreneurs without credit are going to exit. So the type of cycle that we're going to have that they can actually attain in equilibrium is going to depend on this law of motion of the distribution for the entrepreneurs. Right? So let me just show you, at least graphically, how I thought about this. This is the same thing that we had before. Have all of the X's are entrepreneurs. The red ones are the ones that get credit when a bold test is used. Now, after they get credit, the bad ones and some of the ones who received credit, so the bad transparent ones are going to leave. They didn't get credit at all. They exit. Some of the good are going to leave because they die exogenously. The same thing with the bad ones who are opaque who received credit. Now we're going to have some entrants. And these guys are going to come in. They're going to be newborns, all of the blue X's. And you can see that in this particular case, there's more X's in this bad opaque quadrant than there were before. So the fact that we were in using a bold test leads to credit market conditions deteriorating for the next period, right? Now we can think of the cautious test. In this case, the good transparent entrepreneurs are the only ones who are going to get credit from the unskilled investors. The opaque good entrepreneurs are going to get credit from the skilled investors. So now endogenously, all of the bad entrepreneurs are going to exit. Exogenously, some of the good are going to exit as well. And when you have all of the incoming ones, well, you can see that credit market conditions are improving because we have fewer investors in this bad and opaque quadrant. So that's kind of how I think of how the evolution is leading to worsening or improving of credit market conditions, right? So now, once we have this, well, you can see that if you remember what Maryam said, like what I mentioned earlier, how do we choose, how does an investor choose which test to use? Well, it's going to depend on exactly this fraction, this number, right? How many investors we have that are both bad and opaque. So if we have strong fundamentals, and by that I mean that we have few bad opaque entrepreneurs, then investors are going to be willing to take a risk. They're going to have lax standards, sorry for the typo. And in that case, there's going to be a credit and real boom because there's a lot of credit that's being extended and a lot of production. Now, that can lead to weakened fundamentals. When we have weak enough fundamentals, we can just go ahead and have like tight standards now because the fraction of bad opaque entrepreneurs is too large to take the risk. We have credit and real downturn, and then, and that goes back to strengthening the fundamentals. That's kind of how the cycle works. And again, I'm ignoring here some very interesting dynamics that they have regarding of how do you transition, and that's related to how the credit market works and how the loan sizes are determined, how the interest rate is determined. But just simplifying it, this is what generates the cycles. So I think I have 2 minutes left. So let me just give you a few comments. What's really nice here is that the evolution of heterogeneity is endogenous in some way, and it's key to having these endogenous cycles, right? And what I mean endogenous in some way is that the lending standards are going to determine who exits in some sense. And the current type distribution is determined by what happened the previous before, so that's really nice. But what's exogenous is, well, the exit rate, which is fine, but the distribution of new entrepreneurs is given to them, which is okay. But as I was writing my example, I also noticed that it's pretty important in determining whether you're going to have a worsening or an improvement of the credit conditions, right? Depending on how many bad investors come in, you're going to have that credit conditions improve or deteriorate in the model, which is fine. But maybe we want to start thinking for another paper. I know you do a lot in this one, and it's great as it is, but I would think for an extension or for further work, you could start thinking about how this distribution of income in entrepreneurs is determined. You may think of entrepreneurs choosing the quality or the transparent of projects. And it's not obvious how this is going to work, because I think you're going to have mixed strategies, in particular if you are for sure in the cautious stage. But they may lead to shorter busts. And you may also get some time varying correlation in entrepreneur types, which may perhaps amplify some of the cycles that you have. But it would be just interesting to see what are the types of cycles that you can achieve when you allow entrepreneurs to choose what type of projects they want. The other thing is that investors may choose whether to become informed or not. And I think that everything that you've done is assuming that you have few entrepreneurs that are informed, that are skilled. But maybe that's also an interesting variable to think about changing and doing some comparative statics. And finally, in terms of the dynamics, I don't know if you would be able to solve it. I know you may have to simplify some of the things that you have in the model, but thinking about this long-lived investors, even if it's just 2 periods, will mean that the expectations over future credit conditions are going to affect today's credits market as well. And that may also affect the choice of lending standards. So I think that you've done a great job in the paper. I really enjoyed reading it. And these are just some things that you may want to think about for future work. So thank you very much.
Can I ask a question? So I think it's a very nice paper. So I just wanted to know technically, is this a 7-period deterministic cycle? I mean, that's the way you...
Yes, yes.
I think it's just mechanically, usually when you have 7-period cycles, you should have other cycles.
Sorry, 7 period, what did you say?
The way you plotted it, you had a 7-period deterministic cycle.
Ah, it's not necessarily 7 periods. So we can exactly say whether it's like, I mean, so let me show you, like, I mean, the pictures I have are not that great, but there can be like cycles of completely different size. And so this one, for instance, let me try to.
No, but for the same parameters, you can have many different lengths of cycles. But given the parameter set, you would have just a 7-period deterministic cycle.
So that's a good point. So I don't know about uniqueness. So you're asking about uniqueness. We don't have a result about uniqueness. This is about existence. Okay. So I know a bunch of parameters for which this is the only one fixing the parameters. Okay. But because I don't have a result for uniqueness, I don't want to claim that this is always the case. Peter, please.
I guess I would just to add that we don't have any suspicion that there would be other cycles. So even if we don't have the proof, so it's not probably. It seemed that you suggest that there should exist cycles with other periodicity. I mean, I don't think that they do.
I mean, usually when people try to characterize, cycles, they typically, are able to find 2 or 3 period cycles and then maybe use some results to find higher periodicity. What was surprising to me about your picture is you seem to find a 7-period cycle and it is deterministic, right? Did I understand that correctly?
Yes. Yes.
Okay.
I think we, as Peter mentioned, we believe it's unique, but we don't have a proof.
Okay.
I have a question. So I guess I'm trying to understand if there are other tools that investors could use to screen out the defaultant types from the non-defaultant types. And I guess the reason why it seems like it's impossible is because you assumed the same technology for both of those types. So I just wanted to make sure that because when I think about default as a decision, as a choice, and I would think that it would probably be correlated with how productive I am as an entrepreneur. Of course, I think you're just not modeling this part, but I was just wondering if you could maybe comment. So if I think the more productive type, say, would be less likely to default, then maybe you could try to screen the bad type out simply by giving them a smaller loan or something like that. And I mean, I just want to make sure I understand correctly that you're basically assuming technology differences away.
So it's a good question. So we have assumed the technology differences away in the presentation, but in the paper, it is I mean, we have an extension where there is technology, there is no technology, there are technology differences. Okay, however, you cannot, so this is true that that in terms of the decision that the entrepreneur can make, he can only make a decision which is measurable with respect to the to whatever his test gets back to him. Okay, and so in that sense, he cannot make a decision based on the difference in productivity. Okay, I mean, I do generally agree with you that the more tools that you give to entrepreneurs, for instance, getting better information, making less mistakes, stuff like that, they can filter out these guys better. Okay, but that is outside the scope of this paper. So that goes a little along what Cecilia mentioned, that okay, what if they can do better? I mean, if they can get better information, that is possible. That's a different paper, and I think it's a great question. Like, for instance, another great question is, okay, this is exactly as Stephanie mentioned, this is deterministic cycle, but we all know cycles are not fully deterministic, so you would want to add some fragility, okay, with random shocks. And this is actually a very good, with some discussion that we've had with others, this seems to be a very, very productive model to be able to study fragility, okay, with random shocks. And that is another extension that we would love to consider, but we're not there yet. So,
Maryam,
great question.
Maryam, so
great discussion.
Can I ask a last question, super quick?
One last question, okay, while Sydney starts preparing.
Just a clarification. So you have a part, like leaving aside the technology in terms of contracts, you are imposing that you're restricting the contract space?
Yeah, the only contracts are in the form of debt by collateralized debt. That's the only contract.
So potentially they could, if you're large, the possibility that they could screen them or something.
Yes, so we're shutting down every possibility of screening other than using the test.
Yeah.
So just add like very shortly that I think with our assumptions, it's not easy to put together a screening equilibrium because
so there is no single crossing.
Yes, there is no. So no, there is no.
Okay.